Science at York University, not far from here. He's best known to this group perhaps for writing The Cold Light of Dawn, A History of Canadian Astronomy. And he's going to tell us about Peter Millman's Army, Amateurs and Professionals in Canadian Meteor Programs. Richard Jarrell. He's also a member of the ASU History Committee.
Being worse than Tom Hall, I'm Dan here. My talk will fit very nicely from the two that we've had previously, because both set the stage for what goes on in the 1930s to the 1960s, as well as the 1970s with Peter Millman. Tom also mentioned earlier that historians tend to read their papers and professionals just wave their arms. And as a historian, I will read my paper, whereas, of course, when I lecture in a classroom, I've never used the text in my whole life. So bear with me. And when I find that, slides. The theme of this conference is partnerships in astronomy. And few figures in 20th century astronomy represents partnerships more than the late Peter Millman. In his quest to promote meteor science, he forged partnerships between academics and amateurs, between different government institutions, between international agencies, and at a more fundamental level, between people employing different observational methods. In this paper, I will make reference to all these partnerships, but will focus upon the partnerships between the professional and the amateur astronomer. The amateur holds a unique position in astronomy, unlike any other science, except perhaps biology, where naturalists still play a supporting role. The discovery of comets and novae, the monitoring of variable stars, the observations of meteors and fireballs, for example, have long been grist for the amateur astronomer's mill. In meteor astronomy, amateurs played a key supporting role in North America from the late 1920s onwards. How this partnership worked itself out in the United States differed from how it evolved in Canada. A single professional stands at the center of the Canadian story, Peter Millman, whose long and active career spanned the entire history of Canadian meteor science. Millman's most important research dealt with spectrographic analysis of meteor trains. Here, however, I want to concentrate upon the visual observations of meteors and his use of trained amateurs as his army of observers. Peter Mackenzie Millman was born in Toronto in 1906, but grew up in Japan, the son of Canadian missionaries. His interest in astronomy grew during his secondary education at the Canadian Academy in Kobe, leading him to return to the University of Toronto in 1925. He joined the RASC that same year. 4 years later, he graduated in astronomy with the Society's Gold Medal. He was fortunate during his undergraduate years to serve 3 summers as a student assistant at the Dominion Astrophysical Observatory in Victoria. Most Canadian astronomers of the first quarter of the century were trained by C.A. Chan in Toronto, but the latter, with only one assistant, was unable to develop a graduate program. His best students were directed to either Harvard, where Chan took his own PhD in physics, or to California, where he had spent a summer at the Lick Observatory to learn new techniques. Millman moved to Cambridge, where Harlow Shapley was building up a PhD program. In 1929, he moved to Cambridge in 1929, obtaining his A.M. in 1931 and his PhD in 1932. Shapley had a handful of meteor spectra taken some years earlier but never analyzed, and proposed to Millman that he study them for his dissertation. Clearly captivated by meteor science, he remained a further year at Harvard as an Agassiz scholar. While Millman was at Harvard, Chan and his associate R.K. Young were organizing the David Dunlap Observatory. With a major new telescope, it would be the second largest reflector in the world, Chan began to expand the Department of Astronomy. In 1933, Millman was called home to Toronto to join the staff. And in the following year, Frank and Helen Sawyer Hogg joined the department. Frank Hogg was a fellow Canadian and Shapley's first Harvard PhD graduate. Millman had known both Hoggs at Harvard. Because of Young and Frank Hogg, the observatory research program centered on radial velocities, and Millman, like all members of staff, was expected to participate regularly. But he also developed his own specialty in meteor studies. At the time, he was the only Canadian astronomer studying meteors. Millman's initial research combined photographic, spectrographic, and visual observations of meteors. He had already organized visual observers in Harvard in 1932. When he began teaching in Toronto in the fall of 1933, he immediately sought volunteers to observe the Leonids in November and the Geminids in December. Student volunteers were available, and because of his connections with the RASC and the proximity of the country's largest branch of that society, he could tap amateur assistance. The first recruits to his army were only 5 to observe the Geminids, but at one night of the Leonids brought out 32 observers. Millman's preferred method was to set out 5 or 6 observers facing outwards in a circle, with a timekeeper and recorder in the center. This ensured all sky coverage. His base of operations at the time was the uncompleted Dunlap Observatory, which was then sufficiently far from Toronto for reasonably dark skies. Many of you have been out there lately will notice this photograph was taken in 1935. It's back to the official opening. You notice actually 3 trees at that time. It's completely surrounded now. But a very good place to do observing off a gravel road next to a very small village, Richmond Hill. Now, of course, it's completely engulfed in 5 million people, so can't do that any longer. At this time, Charles Olivier's American Meteor Society was reorganizing itself into regions, with directors planning observing sessions and coordinating data collection across the U.S., a plan that Millman thought efficient. He remarked, quote, "It should be mentioned in this connection that Canada is about untouched territory as far as systematic meteor observations are concerned, and that a real aid to astronomical research may be rendered by amateurs in various parts of Canada who would be willing to act as local representatives of the Royal Astronomical Society of Canada in the collecting of meteor observations and in the planning of observational programs." The plea was answered with observations of the 1934 Perseids. In addition to the David Dunlap group, RASC centers in Montreal, Ottawa, Toronto, Hamilton, and Winnipeg assisted, with a total of 45 observing groups and 132 individuals, making nearly 6,300 observations. In Ottawa, Dominion Observatory staff members Miriam Burrow and Malcolm Thompson directed the second largest group of observers in the country. This is a meeting of the American Association for the Advancement of Science in Ottawa, I think in 1936 or 7. And Miriam Berlin is just about center in the second last row. There are 2 women standing. She's the one on the right. Died not too many years ago. Was active for many, many years at the observatory. Peter Millman is, if you see the very distinguished-looking gent in the middle there with a mustache and beard, that's the director of the observatory, Dr. Stewart. And 2 over and just slightly young, smiling chap is Peter Millman. He's the second year professorship at that point. Now back to the Ottawa group. Usually occupying 2, sometimes 3 sites in the Ottawa area, they could be counted upon to observe every major shower. Volunteers came from the local center of the RASC, which was the country's second largest. Over the next 5 years, major showers would be observed from 8 or 10 locations across the country, mostly in Ontario, but with sites as far flung as British Columbia and Newfoundland. Data was then sent to Millman for analysis. In January 1934, he began a regular column, Meteor News, in the Journal of the RASC to report on Canadian observations and on other items of interest in that growing field. Science students were Millman's mainstay at the Dunlap Observatory, and the list includes a number of people who later became prominent in science, including Arthur Shallow, who later got a Nobel Prize for laser spectroscopy. About 1/3 of the observers were women at Toronto, and sometimes more than half at Ottawa. Where sufficient numbers were available, teams of 6 were used, but there were scattered observers working alone and in pairs. Millman published the data on hourly counts in Meteor News, usually trying to calculate averages based upon the average of a 6-person group. These, he believed, were more accurate than counts provided by individual observers. This contrasted with the American Meteor Society's reliance on individual counts. In addition to counts, Millman insisted upon as accurate an estimate of magnitude as possible. This assumed, of course, relatively experienced amateurs, though Millman could not always expect to obtain them. As he noted, quote, "The organization of visual meteor observing freezing temperatures in unsheltered fields, emitting frequent cries of time." Each observer was given a map with a stereographic projection of the sky. Millman's emphasis was upon getting the path plotted and estimating the brightness within half a magnitude if possible, which is not a very easy task if you don't know the sky very well. Once Canada entered the Second World War in 1939, it was no longer business as usual for the astronomy department. Meteor news appeared in the journal through 1940, then lapsed with the first installment in February 1941. In that year, Millman enlisted in the Royal Canadian Air Force, initially teaching aerial navigation, but later working in operational research in London. He ended the war as scientific advisor to the Chief of Air Staff. Reluctant to return to the University of Toronto due to the low salaries there, he considered remaining in the RCAF, but received an invitation from the Dominion astronomer, R.M. Stewart, up there, to take a post at the Dominion Observatory. Knowing that Carlisle Beals was soon to be head of the observatory, Stewart was just retiring at that point in 1946, Millman had worked with Beals at the DAO and highly respected him. So Millman agreed and joined the observatory staff in July 1946 as head of the Stellar Physics Division. Before joining the Dominion Observatory, Millman was involved in discussions with Harvard, MIT, and the U.S. Navy about the possibilities of meteor photography with using pairs of Super Schmidt cameras. Once Beals became director in Ottawa, Millman persuaded him to join the program, and in due course, 2 small observatories were built in Alberta. Meteor work might well have concentrated entirely on photographic and spectroscopic studies, except for a happenstance meeting with PWR or Don McKinley of the National Research Council of Canada. McKinley was a member of the NRC's radar program during the war. He had earlier, as a graduate student at Toronto, lived close to the David Dunlap Observatory, where he used to tramp across the fields with his sister to join in Millman's sky observing parties. He and Millman had met again during the war when Millman had sought out information on radar for the Air Force. In the fall of 1946, Edward Appleton lectured at the NRC on recent British radar astronomy work, noting J.S. Hayes and G.S. Stewart's observations of meteor echoes. Millman had, in fact, visited them in Richmond Park in the spring of 1945, corroborating their belief that they were indeed observing meteors. Both Millman and McKinley attended Appleton's lecture, and afterwards Millman suggested to McKinley that the Dominion Observatory and the NRC collaborate in a 3-way program of radar, visual, and photographic meteor observations. McKinley would handle the radar observations, Millman the photographic. For the visual work, Millman brought in his observatory colleague, Miriam Berlin, who was a veteran, of course, of the pre-war observing parties. Work began with a Perseid shower in August 1947 at the NRC's radio field station, then located south of Ottawa. The radar reported more than 3 times the meteors that the visual observers caught, but Millman and McKinley found a correlation between the longer-lived radar echoes and the brighter visual meteors. The first published data appeared in Nature in 1948. In this slide from a photograph taken in the summer of 1948 at the NRC's radio field station, a typical visual observing group is shown. At the top are McKinley on the left and Millman on the right. The fabric enclosure protected the observers somewhat from the wind, but they were still exposed, lying on cots. Remember, this is Canada, and this is Ottawa, which is bad summer or winter, isn't it? In 1948, Millman and McKinley decided to estimate altitudes of brighter meteors by combining radar with visual observations establishing 2 outstations near Ottawa in addition to the radio field station. Altitudes were then calculated by combining 3 radar ranges, or 1 radar range with 1 visual plot, or from 2 or 3 visual plots. The next phase came the next year, 1949, with the introduction of continuous wave radar to study meteor velocities. After an 11-year hiatus, Millman's column Meteor News recommenced in the Journal of the RASC in 1952. With the success of the Ottawa program and McKinley's moving up the ranks of the NRC's Radio and Electrical Engineering Division, he suggested to Millman that he transfer from the Dominion Observatory to the NRC to head up the upper atmosphere research section of the division. Millman agreed to do this in January 1955, just as planning for the International Geophysical Year began. As the NRC expected to undertake a major effort for ITY, and the radio field station was being engulfed by development of expanding Ottawa at that point, Millman and McKinley urged that a new site for visual, photographic, and radar observations be built. Their plea was answered with the construction of the Spring Hill Meteor Observatory, 32 kilometers south of Ottawa. Headquarters building. Operations began in the summer of 1957, just in time for the beginning of the ITY Meteor program. Although the observatory was an NRC site, the visual work continued to be coordinated by the Dominion Observatory, although Millman no longer was a member of that staff. Visual observing at Spring Hill was a far cry from the open fields of the Dunlap Observatory of the late 1930s. Here's an aerial view of the place. It's a little hard to see. You see 2 large radar sets in the woods. The building that we just looked at is in the center. And up at the top is a small building where the visual observers are. It's almost impossible to tell what's going on there. But I'll describe it to you. Observers worked on the roof of a small building. It was about a half-story building, to give them a good view of the horizon. 8 observers rather than 6 were employed at the time in a circle, with a timekeeper in the center. For protection from the elements, each observer was encased in a wooden coffin, so that only their heads and shoulders were outside. Heat from an oil furnace below was then piped into the coffins, and the timekeepers stationed in cold weather. And mind you, you get to -40 up there. Observers lay upon platforms with a raised back and a foam mattress, and each was equipped with a map and a pen, which held a flashlight, a rheostat to control the illumination, and a button that connected to the radar recording device. When a meteor was observed, the button was pressed, and a match could be made for the visual and radar record. During ITY, joint visual and radar observations were made for the 71 world days and 10 days of peaks and showers. During the late 1940s and the early 1950s, RASC observers continued to send meteor observations to Millman. The Montreal Center was particularly active from 1946 onwards, joined in the early 1950s by the Regina Astronomical Society, which coordinated observers across Saskatchewan. By the mid-1950s, other groups in Winnipeg, Fredericton, Deep River, and Ottawa could be counted upon. For the 1956 Perseus, for example, the Regina group organized 82 observers across the province. Millman did not direct any of these groups, but acted as the clearinghouse for observations, which he then published in Meteor News. Amateur participation was an important part of the NRC's ITY program. Millman announced in the journal that he would send out instructions and pads and maps to amateurs anywhere if they would send back data to the NRC. Response was excellent, and he soon had new recruits for his army. As usual, he emphasized group averages and careful magnitude estimates over 10-minute intervals throughout a shower period and on world days. Many of the RASC observers who had already worked joined in, but the response from the United States was even greater. By February 1958, we're not even through the ITY year yet, he reported data from 367 observers from Canada, the USA, Puerto Rico, England, Jamaica, and Switzerland. Within a few months, reports came in from Italy, Brazil, Japan, India, New Zealand, the Philippines, and South Africa. By the time ITY ended, he reported that some 93,000 meteor observations were entered on IBM punch cards. Some institutions decided to carry on the collection of geophysical data after the and the NRC Visual Meteor program was one of these. From 1957 until the end of the program in 1967, Millman received observations of some 277,000 meteors, mostly from Canadian and American observers. I should point out one thing. When I picked up these slides, the head of instructional aides at New York University is also named John Briggs. Pulled this out and he says, "What in the hell are these people doing?" But I think what I really particularly want to point out to you is that if you look at the Sky and Telescope in the 1950s and the early 1960s for meteor star parties, inevitably they're all wearing Hawaiian shirts. But Canada is a very different place, as Peter has already discussed, that everyone wears a coat and tie, even when you've got mosquitoes, and even when you're out observing meteors.
Or at least when you're going to get your picture taken.
After IGY, operations slowed at Spring Hill. For visual observers, 12 were normally present for visual and camera operations. Working a full night and having to drive out from the city, the most efficient use for them was to work only at times with showers. Still, the data were impressive. Between 1947, that was the year before this photo was taken, and 1969, the NRC's volunteers, these are just the ones hired working with Millman, observed 41,000 meteors at the radio field station in Spring Hill. Coordination of visual work by the Dominion Observatory ceased in 1970 when the observatory was closed down, and its programs were transferred to the NRC's Radio and Electrical Engineering Division. Ian Halliday, who had directed meteor studies at the observatory after Millman's departure, joined the Upper Atmosphere Research Section along with his staff. As McKinley was now a full-time administrator, and Millman would formally retire the next year, the move was timely as it allowed Halliday to keep meteor astronomy alive, although it moved into quite different areas. By the 1980s, continuing cuts to the NRC budget began to take its toll on the program. Spring Hill Meteor Observatory, by then only used occasionally, was closed down in the late 1980s and sold. When Halliday and his senior staff were retired by the early 1990s, the Meteor program had ceased altogether. Peter Millman saw the winding down of meteor studies with some sadness, but as he related to me in 1989, science always moves on. He had the satisfaction of knowing that some important questions about the nature and origins of meteors had been answered, and that his work had been an important factor. The partnerships that Millman encouraged allowed Canadians to have a high profile in meteor science. His organized use of amateur observers for visual and photographic observations followed quickly on its inauguration in the United States, but with a much smaller army. His group count technique and emphasis upon magnitude estimation ensured valuable scientific results. Visual, radar, photographic, and spectrographic work were typically separate in the late 1940s, but Millman, by bringing together the Dominion Observatory and the NRC, could enhance data collection by coordinating all four with the resources of two institutions, plus volunteers. His efforts to bring together expertise on impact features made Canada a world leader in the field of meteoritics. His first publication on meteors appeared when he was 24. His last was penned when he was 84. Peter Millman founded the field of meteor science in Canada, and it was his ability to forge partnerships that allowed it to blossom.
Thank you very much. Any questions?
Comment, the question, I really am tickled by that picture with all the ties because I had the same observation about telescope makers. They're always in shops with their ties on and pointers grinding away at the telescope drum. But what I wanted to ask is, if you know a kind of a formal tie between AVSO sequence estimates or sequence charts and Millman's efforts to get people to report magnitudes for meteors, do you know if in fact there was some connection between the methodologies that were involved?
If there was a link, it probably would have to make it harder when he was down there, because that's when he first started doing this. There's a, I think where the article is. I think perhaps it's in the article that he and McKinley wrote for the Calco Middlehurst volume on the solar system. multi-volume thing, and his section on meteors in there. He talks about in the 30s, there were several different attitudes about how you took visual observations. The English observers, which had begun right at the beginning of the century, were still active, were always, they wanted the precise path, and they wanted the radiant location. There had been a group of Harvard people went down to Arizona in 31, 2, something like that. They had a slightly different thing. The people working out at the Harvard fuel station had a slightly different one. And so they had about 4 or 5 ways you could gather data. And he decides it must be about 32, I think 32. This is the way to go. Try to get the path, don't worry about the gradient, but try to get the path you can and get that magnitude as closely as you can. And other groups just didn't worry about magnitude much at all. So you find all these data right into the late 60s. That's always the emphasis.
All these observations, 277,000, are they somewhere? I mean, where's the original data, or is it just available anymore?
Well, I can't get anything to read IBM punch cards anymore. That's what they were on. My suspicion is that they probably ended up in the basement of the Hertzberg Institute in boxes. And Hertzberg Institute left Ottawa a couple years ago to Victoria and left behind almost everything. In fact, I was tipped off that there were some boxes of files of the radio astronomy section, which I'm working on right now. And, so I nipped in there and grabbed that stuff before it got chucked. But I was told at the time by the archivist that there were literally whole rooms full of boxes of old IBM punch cards. And a lot of Millman's stuff is up in the NRC archives, but I don't think much of that kind of data. I think once it was published in tabular form, who cared? That was sort of the attitude. And there was no staff. Once Halliday retired, I was in for the actual section for planetary studies was killed about a year ago. John?
I think I should just mention for everybody, anybody interested, I heard a rumor about 2 months ago that this, the late Bill Blitzstein, if I'm pronouncing his name right, at University of Pennsylvania, had in the basement of his house a lot of archives from Flower and Cook Observatory. Some people are sort of casually going through these things to preserve what ought to be preserved, but apparently there might be quite a pile of records in there from the early days of American Media Society. Just thought I'd mention it, because you both, it is outside of Philadelphia. Bart Freed is the one who clued me in on it. I just thought I'd mention it. Talk to me afterwards and I'll make sure.
Well, I served in Peter Millman's army for 7 years. I'm just curious if anybody else here also was part of the observing groups.
Well, I was, the 2 times I was paid to do astronomy, I was out in Alberta in the summer doing this sort of thing, but it wasn't, I guess, part of his army.
I never got paid. I was going to say I served in the trenches because we didn't have the cushy Spring Hill Observatory. We sometimes had to dig in the snowbanks in Montreal that were this high, literally below the snow level, which was a lot more comfortable than if there wasn't snow on the ground.
You didn't wear your tie.
No, I didn't wear a tie.
I suppose I wasn't part of the Army. I was one of the results of it, where he's encouraging amateurs. It really was something to bring together the observers in Ottawa, and that's where I really got started, is meteor observing using Millman's techniques, and really began to certainly didn't last long if you didn't get in things in order and start being careful about your observations. And that continued on for another 10, 15 years or so.
The point about not worrying about where the radiant was, once they were all plotted on the charts, you had the radiant from 100 observations or more.
Moved.
Yeah, well, we do it hour by hour.
What did Dr. Millman do after he left this program?
You just kept on working. He had his office. I've never seen such a mess in my life. Worse than mine. He had stuff stacked to the ceiling. They put in, as NRC has a wonderful way of doing with their senior people, they put them in little cubby holes. But he had his entire career's work there. So he was crammed in there, and Ian Halliday was on the other side of the partition, crammed with his stuff in there. You'll see he was at the retirement stage. He just kept writing. He was encyclopedias, always wanting to study. He had lots of data he had to grind out. He was active. I probably still doing scientific papers, especially on meteoritics, right up until he was about 80. And certainly from in his 80s, he was still doing encyclopedia articles. Meteoritics became as much bigger interest. It's a whole other story, really out of the Dominion Observatory, the Geological Survey. It's a fascinating story in its own right. But Peter got involved in that over the years. The Spring Hill thing ran itself, basically. The radar thing was on 24 hours a day. You just had a technician keep track of it. And it showers, and you got people with ties out and roll the coffins. I don't think he actually went out there very often. Peter?
My feeling is that the raison d'etre for meteor observing from the end of the Second World War until at least the end of the International Geophysical Year was to find out about the composition and density of the upper atmosphere prior to the beginning of the space age. Do you have any feeling as to whether that allowed the meteor program to continue and in fact then correspondingly led to its demise once that information was available elsewhere?
To get it going, you're absolutely right. The upper atmosphere story, in fact, that's exactly how I got the money for the Vino and Newbrook observatories in Alberta. Because he went to Beals, because he'd been talking to the U.S. Air Force, and he said, what we need to know this upper atmosphere thing is, was to think about ballistic missiles. He said, we got to know what it's like up there because we have those fanatic Russians, etc. And that was the pitch they made. He had no problem getting the money. And in all the Beals correspondence, he keeps referring right up until they did get things built until about 1952. At which point, by the way, the Harvard people already figured out that they didn't need meteor data for the upper atmosphere anyways. But a little late for that. But Beals throughout that whole time was always referring to this joint U.S.-Canadian defense project. That's how it got. The RCAF sent a plane down to Cambridge to fly the Super Schmitz out of Alberta. It was all very nice. By the time you get at IGY, of course, that Canada was a very big player in IGY, and the NRC was in the center of that. They're doing, Millman's group is also doing auroral studies. They were very involved in that, and a variety of other things. By the time you get into the certainly into the 60s and 70s, it's probably a good question, why do we need any more of that data? I think toward the end of his life, Peter understood that, and sort of life feeling, talking with him, that, well, we did it. You know, you could go on, the same thing when they closed down the two observatories, the Super Schmidt observatories out west in 1970. They ran out of budget, and they said, well, what's one more, a couple of photographs taken a few kilometers apart of the meteor, what's it going to tell us that we don't already know? And they all admitted, right, well, we can be redeploy this